Hello, my name is Mike Chen. I'm a cloud solution architect in data and AI from Microsoft Hong Kong. So today I want to share with you how to use Azure Machine Learning Service to perform low-code development on machine learning. So you must have heard not about ML, AI in the past, but usually people want to make use of it, doesn't have the time to drill down to details like which algorithm to use, how to do it step by step, or even you don't know how to hire people that qualify to the job. So that's I think Azure Machine Learning Service will come to help because it closes the skills gap. It provides you automated machine learning, so you don't have to worry about how to choose the best model or algorithm for you. And then you can use some simplified drag and drop interface to develop your own workflow from data preparation, choosing a algorithm to how to deploy your model. So other than this, I will also share a quick demo on how to do it without even touching keyboard because it's no code, right? So let's get started. As I mentioned, we're going to go through how to build machine learning models with low code in our section. Um, as I already introduced myself, and then just to make sure that you can always download all the materials we presented in below URL, and then you have the section code, you have the event section resources. What I want to highlight is that you will see some differences between those GitHub and resources name and what I presented today. The reason why is that our platform is keep changing. So if you see a lot of updates on the latest interface or the thing I've presented, is because it keep on evolving itself. Just like the deep learning, you have the new options which is not covered by those resources are listed. So just to make sure you have the you can taste the latest version on Azure portal actually yourself. So feel free to browse those resources and get your first hands-on labs ready. And then this is today's agenda. What's machine learning? I think you already heard of that many times. And then when is machine learning the right tool? And then we're going to talk about how Azure Machine Learning Services tool will make your life easier. Because at the first page, we will take a look on, okay, if I want to do machine learning in the past, just like what I did in my past actually, I do a lot of Jupyter Notebook to weigh a lot of machine learning models, and then I think about how do I deploy it, how do I code it, a lot of code base. We need of collaboration within the teams, and then we need to take a look on new tools, okay, to make our life easy to share as well within a workspace, and then we can build a model with local using Azure ML Designer. Today I want to give you more. So I will try to incorporate another tools called automated machine learning within our demo. If the time is allowed, just for your reminder, but it's really easy to follow, to be honest. Later on, I will post you the link. How do we get into the details and tutorial? How do you build your first automated machine learning within Azure platform? So it's not magic, to be honest. As long as you have some Azure credit to deploy the machine learning compute target, and that's it. So, and also we have the deploy and test and consume the model. In Microsoft, we emphasize we have a operational guidance, which is what we face as ML ops. So we not only taking care of the training, which is the sexiest part of the machine learning, right? People have been talking around how do you train the machine learning model, but we also take care of how you do version control, because in machine learning world you train a lot. So you want to version control on the model itself, and also how do you deploy and test it, Because if you're not going to easy using the model, it's not going to be useful for your organization. Only you, the developer, will know what is behind the scenes, but not the others. So we try to make machine learning accessible for everyone. So we take a look, we emphasize on the deployment part and then how do we influence the model. I will explain what is influence later part. So don't worry about those terms as you're not familiar with. And then, okay, so that's it. Today's agenda. We go by code base, and then what is the disadvantage of code base, and then we talk about how the Azure Machine Learning Service solve the problem. So we'll follow a use case today, which is really similar to what I've done before as well. So it's basically a sales forecast. So if you take a look on this Tailwind Traders, they sell lots of grocery and then with maintenance tools, I would say, in different store. So they have a lot of screwdriver, and then saw, and then other stuff, and they want to predict how many purchases per store will happen. So they have lots of data, and because they want to they want to utilize, maximize the profit, and then optimize the supply chain. They want to forecast how many sales per item per store on each day. So it's challenging, and they think the machine learning is the way to do that because everyone's talking about you cannot do a lot of forecast recommendation engine with machine learning, but at the first place we will ask ourselves: is this the right tool? Is it going to solve the problem by this way, or is it? Are there many other methods available to solve our problem? So we take a look, we take a step back and ask ourselves, what is machine learning? And so it has been around from AI, ML, and DL. So DL is the deep learning. We have been incorporating these features in Azure service. So let's take a look on AI. So AI is a technique and enable computers to mimic human intelligence. So it inclusive to machine learning. So machine learning is part of the AI. So if you, I think you already heard the news that AI is beating human in computer games, on chess, and then on simulating some model in, say, for example, virus outbreak. Those things can be accomplished by the AI. And then AI is a term that describing all the things that as long as we teaching the computer to mimic human intelligence, making decisions, etc. And then there comes the part, the machine learning. So it's a subset of AI. Only we talk about improving the task with the experience, like keep on repeating the same terminology, testing how many algorithm is the best for me, and then the big part actually for machine learning is the recommendation. Think about you as a human. You have to say, for example, your boss is asking you, okay, please give me and suggestion if I buy this item or not, for example. So you will keep on researching, you keep on guessing your boss preference. So that means actually you're doing something that improving the task that your bosses want. And then this part is actually the machine learning part. And then you have the deep learning. Deep learning is part of the machine learning. It's all about neural network. So basically, it's nothing magical here as well. We deploy the neural network to have multiple layer of the machine learning instead of one layer of the training. So it means more training you have on the behalf, but it's more precise in accuracy. And then to be honest, we have more deep learning service upcoming. If you have been noticing Azure platform, you'll find one of service is called Personalizer, which is already a deep learning enabled machine learning services on our catalog. So this is one of the part. And then when you go through the demo, I will show you also deep learning can be enabled within the machine learning service. So it's still in preview, to be honest. So you can expect there may be some error within, but you can see that, okay, machine learning service can enable a deep learning capability, and then all of them are within the scope of generic terms AI, artificial intelligence. So that's just how we define machine learning. And then as I mentioned, once you define the problem and then you are trying to see whether machine learning is the best method for you to solve your business problem, right? So we have to take into consideration that whether the traditional programming is the same as machine learning. So if you're already programming things, you have the algorithm and then you have the data. So um, try not to use algorithm here because in traditional programming, what you have been doing is actually deploy some logic, right? You are trying to implement some logic for your data processing, and within your input of the system and the deployment logic, you have the output. So this is what traditional programming has been giving you today, right? So, but in machine learning, the things are different. The algorithm is your output. Is the thing you want to find. So in the machine learning, you still have a lot of data, which is the biggest part of machine learning actually. And that's why I have been working in the data engineering field. And there's lots of discussion, like 80% of your time in machine learning project are actually cleansing data, preparation data, and that's actually true in my experience as well, because you don't have many data to train, not enough clean data to train, and then you have a model that really distort. So let's get back on to this one. And then you have the machine learning, and then you have the data input. And the second thing you want to input is the output. Uh, or we can say the the thing you want to predict. And then output is one of your output is your one of your input. Well, what's the meaning of that? Is because you want to predict something. You want to tell the computer, okay, this is the output input I want, and this is the output. Give me your algorithm. Give me your logic. So what we call it in machine learning, we call it labels. Because say for example, in supervised machine learning, you may want to label, okay, this is the winning. So this is the winning case. You have to determine what was the winning factor for me in as an algorithm. So that's what we call labels. We will talk about data as an input as well. You notice the word features, right? So features is like if that is relational data, just like in table or CSV, most likely a feature is a column itself. So we will examine whether these features is related to our analytics or prediction. So we call it features. And feature engineering actually is a big part in machine learning. We'll see that later. And then after your machine learning process, you have the computation. And finally, you have a model, which is actually an algorithm. So that's the machine learning procedure. And yeah, that's it. Model and as an algorithm. Just to remind that in the past, when we talk about data warehouse, we also talk about data model, right? One fact table and then several dimensional table. So they are actually the same thing, but how to say that? On the visualization part, data model and machine learning model is different thing. Most likely in your machine learning model, you want some inferencing part. You want to reuse it without a lot of data input. But in data model, in the data warehousing, it's just like a star schema, right? So once you input more data, it generates a prediction for you, or in the BI, it shows you the latest forecast. So a little bit different if we're talking about the generic term of modeling. Yeah. And then we have what is machine learning? When is the machine learning is the right tool? Prediction, forecast, quantity. Sorry. Start with a question to ask is that whether the sales forecast quantity per item per store for the next 4 weeks, and then you may have 3 years historical data. That makes sense for you to use machine learning actually. And then if you take a look on before Azure Machine Learning surface, just like me in the past, if you want to use, okay, I need to know machine learning part, but how do I get started with? So you have different algorithm. You may heard of when you're in your university. To be honest, when I 10 years ago when I was in university, I already learned neural network and clustering, regular expression, etc. But I never thought because they to that point, I would say the computation power is not yet powerful that people paying attention. But with the cloud processing power and then the flexibility, so people are taking more attention in the machine learning. And that's why we say in the cloud, in the age of cloud, there comes with the machine learning services. And go back to here. So when should you use the machine learning? And it translates into which algorithm actually you should be using in the machine learning. So we have the regression model, we have the classification and clustering. I want to explain a bit one by one. So regular expression regression, I think you already heard of that. You define a formula that when this happen, how much or how many will be in our forecast. So this is straightforward. And then we have classification. So say for example, if the customer walk into your store, he or his gender and then the age group, you classify them into high possibility to purchase or low possibility to purchase, and then you do different marketing campaign, right? So this is how we do classification. And then we have clustering. Clustering is a little bit different to the classification. um, they we were trying to find this new data or in the past data, which cluster we try to find the features they share with, and then we cluster into, say for example, different age groups. So it's defining by the clustering, and then you would see, say for example, different circles of the cluster, and then we have the abnormality detection. It is weird. It used a lot nowadays when you do the banking transaction. We want to detect whether it's money laundering, someone misusing your credit card for your unauthorized transaction. Is happening a lot in the online business as well, PayPal, etc. And then you have the recommendation engine. Which option should I choose? I think you're already familiar with that because on the online platform, e-business nowadays, it's really common to have the recommendation engine. So when you want to use the machine learning to solve your problem, you have to take care of this kind of thing. And then you may heard of the word supervised learning and supervised learning as well. So we'll talk about it later. We'll talk about it here as well. So supervised learning is you teaching the computer this is right or wrong, or this is the result we expected. So you manual tagging with the customer. Okay, you teach him what is the result look like, and this is what we call supervised learning. And then in unsupervised learning, things are totally different. You don't tell the results to your computer. You're only telling that you just kept telling the computer you have to learn on your own. So that's why I said classification similar to the clustering, but not the same thing. Because in clustering, you never tell your computer they have to find the co-shared features within the data. So that's what we call clustering. But in the classification, you already know what features that may contribute to the classification. So that's the two differences between. So I bet you already heard of them because unsupervised learning is taking a lot of attention today. As I mentioned, we have the personalizer, which is the usually used with the recommendation engine. Is actually an supervised learning experience as well. So we are not telling the computer people prefer the branches always will go to a brand T-shirt. So it's a recommendation engine, right? But we are not telling the computer. They are identify this correlation themselves. So this is how we do unsupervised learning. And then in a typical model building process, we have preparation of the data. We have trained the data. We prep a cleaned data for the input, and then we train the model, and then we test it, how many score is telling, and then most likely in all cases, you split the data as training set and verification set. Um, I mean, 70% go to training, etc. And then you deploy the model, which is the which is one of the missed part when we talk about machine learning. Usually, people would pay attention in the training, but we want to emphasize deployment is a big part for your whole journey for ML ops as well. So of course we have the data preparation, to be honest, which is used as lots of time, and this is how we do. I want to remind that it's a ever looping cycle, because once you have you wouldn't have a perfect model during the whole time series. Your data model should be keep on learning himself, improving himself with the latest trend. So if you have some outbreak of the, say for example, world event, you want the model to taking care of those things as well. So your model has to keep evolving. And then I would mention PEP the data. We're not covering much today because I will already show you on Azure Machine Learning Surface how do you PEP the data. And to be honest, if you're already familiar with the data platform, you should be able to define all the data preparation on your own data platform. So today, I'm going to show you some simplified version of data preparation, and then you find features within the data, and you will want to find and validate if enough data is available, which means you want to find, okay, I want to make this decision whether I have all the enough data or relevant data on my hand. And then you want to gather all the external data. Really popular is weather forecast. You want to take, say for example, if you want to forecast your store analytics, you definitely will go to weather, right? And also, there's really long in data science or machine learning, we have been using the New York taxi, the data to train a model. How many taxi and how many tax wives, how long they will be. And that data actually is severely affected by the weather forecast, the weather data as well. So although also we have the future days for data set to get the prediction. And so it's just getting the future date, nothing magical here. And you in a traditional machine learning process, you have to find and validate data on your own. You have to find the missing gaps in data. You take a look on each row. Okay, do we have some missing data as well? So it's I think it's tedious, and then you spend a lot of effort on that one, and then you're adding some indexes to data, do a lot of coding from now on, and then you have to do the feature engineering on your own. Just like this one, you're taking the to account because you're doing sales forecast, right? You want to predict the sales in season, how many holidays, how many features, how many fourth year is the seasonality of each quarter, and then we have the lag features, and then how many this value, period time steps, and lag behind of the data, etc. So this thing, if you're doing normal machine learning case, you have to taking care of as well. And then we have the demo. I'm not going through this step by step because this is one we want to avoid nowadays. We want to, in the past, when you talk to a data scientist, what they have been doing is that they use some programming that only they know to calculate all the machine learning data model. And then you have a lot of extraction from the code, etc., etc. So this will not be our focus today. In the result set, after a notch of programming, um, you have the data set, but it's still not yet a data model that you can keep on reusing. So this is why we want to introduce you the Azure Machine Learning Service. So if you take a look on the value, and then we have the model building process. So we train the model and then select the right algorithm. So you have to hire someone capable as well to do the machine learning for you. Even you take a look on the algorithm chassis from us, it's like it's not for someone out of the college, to be honest. And then you have to classify the image and prediction between two categories and predict between several categories. And then you have to learn a lot just to understand this chassis. And then, but we want to simplify that. We want you to be able to build and test and train your data model right away. So that's why we want to introduce you Azure Machine Learning Service. And then if you go to this one, it's a offering tool, and then you have automated machine learning, you have Azure Machine Learning Designer, and then lookbook, etc. So you can also deploy your assets and dataset, etc. thing, and then the management. So it will better to show you to on our workspace. The studio experience is the best space to learn. I'm not sure. Okay, it should be. I should be able to go to there now. Let's go to the real thing. So if you take a look on my screen, I'll be showing this one. Okay, so this one is how machine learning service already powered your suggest replies on Outlook. So we have been heavily using our Azure Machine Learning Service internally, and you actually has been using it as well as the user. So that's the interesting part. And then if you go to the Azure portal, and then so this is my portal, and then if you go to check it out, machine learning service, you'll find that you can create a workspace for you to use, and you define your workspace, and then my demo workspace, etc. So you're creating your own workspace, and after that, you can take a look on my result set. So this is my machine learning service studio. Wait a minute, I want to go back and then give you some step-by-step experience. So once you create the resources, you will find this one is the machine learning. And then if you click on this one, you will have different options here. It's even more simplified to the Kubernetes, I think. And then if you want to try the new Azure Machine Learning Studio, it's a preview experience, but it's simplified for you. So I click launch now. And then what we'll be focusing today is the designer, because as I mentioned, today we want to talk about some low code experience. So designer is the one you should go to. And then if you click on this one, you'll find we already have some samples for you to taste it. I want to introduce a bit about what we have here today, what we have in the Azure Machine Learning services as well. So we have the notebooks, which actually is the notebook experience for your machine learning experience, and then you have the automated machine learning here, which actually can do a lot of feature engineering automated for you. And then we have the designer, which is a drag and drop experience for you to design your machine learning workflow we'll go through it today as well. And then data set, which means that you store your data in this way. You can reuse the data set in other machine learning pipeline, and then you experiment how you want to run your machine learning model with the hardware, with the infrastructure. And then pipeline, similar thing, but a pipeline can belong to different experiment. And then you have a model. So model will be the training result and the deployment unit in Azure Machine Learning Service. And then you have different endpoints as well, pipeline endpoint, real-time endpoint, etc. So we'll be using a real-time AKI Kubernetes service for the endpoint as well today. And then you have compute. So in Azure Machine Learning Service, you can decide which training cluster you go to, which machine you want to train on. I just choose something called standard. Standard is the VM size, etc. And then you can decide, okay, how many VM machine I should be used for training my model. And then you have the data store, etc. So let's go to the designer. So I want to explain a bit on how do we build a machine learning from scratch. So if you want to follow this tutorial, and then you can click the ease of use pre-built modules. So in this part, you'll find that you can have just like a design studio, and then you can drag and drop what you want to do. So say for example, I want to, okay, firstly is my data set. And most likely, I mentioned the data preparation, right? So you want to click into here and then split, maybe remove some data, etc. And then I want to actually remove select the column in the data set. I want you to only focus on one of the columns within the data set. It's a CSV file, and then, okay. So that's it. So once you have this one, and then you can select all the columns, and then I want to exclude one of the columns that it doesn't make sense to me. So that's why I'm excluding one of these. I think I have maybe using I will remove the duration, and then you save. So in this step, once I have the CSV file upload to the cloud, and then I have to select one of the columns, you may want to split your data. So when you split the data, which means that you want to have something training set, and then one of them is verification, and usually I would do 0.7, so which means that 70% of your data goes to training set, and then 30% will go to verification. So that's how you do it, and then you define a algorithm for you to train the model. So if you're familiar with this tool, you don't have to each time drag and drop. So one of the features you may find is when clicking, okay, I want to train some model. So that's how you do it. And then you split the data here. Here you'll find the left and right hand side is different. The left hand side is the training data sets, which means 70%. And then you randomize the spread, and then you go to train the model here, and then I want to but how do you input as the algorithm you want to train? So right now you would take into account of the how to say that, algorithm, yeah. So which means that we actually designed the algorithm for the training data model. So it's a supervised learning, and if you don't mind, I need you to go on this one. Yeah. Vector expression, yes. Yeah, linear one. So linear regression as the training algorithm, and then you have the training. So as I mentioned, we have to score the model. We want to take a look on, okay, how accurate is my data. And then you will use the evaluation data as the scoring as well, because those so always remember you can have 30% of data that is verification, and then when you do after the training algorithm, you may want to score it how important is that for you. No, sorry. How accurate is the model with the training data model trained, and then how accurate will be with the testing data set, the 30% of the data. And then lastly, you will have the evaluation. So you want to evaluate your model, and it just gives you the output. Okay, how I want to do, how well is the scoring given the testing data set. So that's how you do a low-code machine learning model. And then if you, okay, it doesn't look good, right? So you can always auto layout the machine learning model. So that's how you do it. And once you click the submit, you will have all the process how do you say that? All the workflow triggered by you. So let's take a look on one finished training and the whole pipeline for you to take a look on what's going on with this one. And then I think, yeah, that's the one. So you can see that this is done by me last slide as well when I packed the tutorial and demo. And then you can see that it'll execute all the things step by step, select each column, and then key in some missing data, and then you split the data within the within this 70% and then 8%, etc. And then it will give you how well the score actually it is. I mean the scoring here, and then if you give you the input as well, you can take a look on how accurate the model. So this is how you do a drag and drop machine learning model. You can tell that I didn't do a lot of programming. In fact, I never did any programming, if the nulls, etc. Nothing happened in this data model. So it's one of the best thing happen is that you don't have to code a lot, and then you can see each step whether there's an error, and then how well is that trained, and then you have to evaluate results as well. So if you want to take a look on the details of why the model training in this way, you can always click on the explanation. To be honest, it's still a preview stage, so it's not a completed experience so far. But if you take a look on our data, other models like matrix or images, you can take a look on each step. How long does it take? What is the result set? Anything stuck in the log file? So it's everywhere for you to take a look on the experiment. So after that, after you have a machine learning model, what you want to do is actually to deploy the model, right? You want to keep on using the same machine learning model, pre-trained it, or later on you want to retrain it. So when you're on the model and you actually have the options to deploy it, just keep it 1 second. Yep, in the model. So you click it and you have the deploy button. So when you have the deployed it, you can choose a Azure container in Azure, I think container registry should be, and then I have been using AKS for me to influence the model, which means that the next time when you import some new data, it can automatically keep you the prediction value when you have deployed in the endpoint. So this is how we do the machine learning and then deployment, just one click experience, and then you have all the thing deployed for you. Because I deployed my machine learning model in West US, so that's why it's slower than usual. But in most cases, it's much faster than we. And then one of the new features is that in the Azure Machine Learning Service, once you deploy the model to an endpoint on, say, for example, AKS, you can test it. You can give it some some latest input, and when you click that, it will give you the predicted value based on your input. So say for example, if you want to predict, so this one is predicting how much whether this guy will be subscribed to a loan for his house or her house. So you give them the input, it will give you the test result, whether it's going to be scored a label. We're going to predict whether it's going to subscribe to the loan, etc. So it's quite convenient for you to test the endpoint. And then you have the consume model as well. So give you some code or some REST API for you to postman to test. Okay, if this guy is 21, he have this income level, will he or her subscribe to the loan fund for you? So you can make your own decision based on, okay, he will subscribe to the loan based on our current data model. Let's go with him on some marketing campaign or include him in the coming event invitation. So that's how we do a machine learning deployment and consumption. So I believe you all so you have some taste on what we're trying to do with Azure Machine Learning Service. And because today we don't have enough time to go through all the materials, so if you want to learn further, you can always go to MS Learn. We already have the full end-to-end machine learning surface tutorial available for you to compare it, watch the video, and practice on your own. So I think that's really good resources for you to learn our platform as well. So thank you very much for watching, and let's get back to on the Q&A section.